Alright, the next video is still about functions, and we're going to be looking at composite functions. So composite functions can be a little bit confusing when you first look at them, but if you just go step by step and think of inputs and outputs, it really becomes a lot easier. So composite functions are functions of functions. We're just going to go one step at a time, so it's nice and easy. Let's start off with an example, and first we're just going to look at a regular function. F of x equals 2x plus 7. So if we have to find f of 3, we know what to do. Instead of x, we write 3. We substitute in 3 for x. So f of 3 is equal to 2 times 3 plus 7. So we say 2 times 3 instead of 2 times x because we're finding f of 3. So f of 3 is equal to 2 times 3 plus 7, which is 13. That was easy. You knew how to do that last year in Algebra 2. No problem. Let's look at another function, g of x. G of x is equal to 3x minus 27. So we can try to find g of 13. Same idea. Instead of x, we write 13. So g of 13 is 3 times 13 minus 27, which gets us 12. So g of 13 is 12. We got that by plugging in 13 instead of x. But what if we were asked to find g of f of 3? Looks very confusing. But if we just think of this one step at a time and know that we're finding g of f of 3, meaning that f of 3 is going to be our input. All we have to do is find f of 3, and then we use that as our input. So f of 3 we know is 13. So g of f of 3 is the same thing as g of 13, because that's what f of 3 is. So instead of f of 3, we write 13. Now we have to find g of 13. Well, we know what that is already, right there. It's 12. G of 13 is 12. We already knew that. So in other words, g of f of 3 is the same thing as g of 13, which is the same as 12. So g of f of 3 is 12. I know it looks confusing, but if you just go one step at a time and concentrate on what is our input, what is our output, what is our new input, and what is our new output, it becomes pretty straightforward. So here's another example. Let's say we have h of x equals x squared and g of x equals negative x plus 2, and we're asked to find g of h of 3. Fine. So what do we do first? Well, we need to find out what the inside is, the h of 3, because that's our input for g. So h of 3 is what we need to find, so let's go ahead and find that. H of 3 is 3 squared, which is just 9. How did I get that? Because h of x was x squared. So h of 3 is 3 squared. So h of 3 is 9. We got that. Great. So now we need to find g of h of 3. But h of 3 is just 9. So we're really just looking for g of 9. So let's find g of 9. Well, g of x is negative x plus 2. So g of 9 is negative 9 plus 2, which is just negative 7. So g of 9 is negative 7. So g of h of 3 is negative 7. Why? Because h of 3 was 9, and g of 9 is negative 7. So g of h of 3 is negative 7. We could also go the other way, and find h of g of 4, for example. So first we have to find g of 4. G of 4 is just negative 4 plus 2. I'm using g of x as negative x plus 2. G of 4 is equal to negative 4 plus 2. So g of 4 is negative 2. So now we need to find h of g of 4. But we know what g of 4 is. It's negative 2. So we're really looking for h of negative 2. Well, h of negative 2, using h of x as x squared, h of negative 2 is negative 2 squared, which is just 4. So h of g of 4 is just 4. Why? Because g of 4 is negative 2, and h of negative 2 is 4. We just plug it in. So those are kind of straightforward because we're just dealing with numbers. Sometimes it gets a little more complicated when we just need to find an equation for, or a formula for h of g of x, for example. So h of g of x, now we have an x in there. Well, we know g of x is negative x plus 2. So h of g of x, well, that's, instead of g of x, we just write negative x plus 2, because that's what g of x is. So now we're looking for h of negative x plus 2. H of negative x plus 2, we just plug it in to h of x equals x squared. So we have h of negative x plus 2 is negative x plus 2 squared. So h of g of x is equal to negative x plus 2 squared. So the composite functions, again, they're just functions on functions. You just go step by step. You work from the inside out. Using the innermost input, you find the output for the inner function and use that as the input of our outer function.